Let's go back and pick up BMS. So
Sure,
let's
sure.
talk about a battery management system, what students should look at, and what kind of aspects would be helpful for them.
So battery management systems are super critical. With lithium cells, lithium battery packs, they're a must-have. But they're not all created the same.
Right.
And there are some lower cost ones that you would see more common, I would say, maybe in the sort of smaller power needs areas, where I would call them like a dumb BMS, where there's nothing to let you know what they're doing or where they are in the state of how close am I to having a problem.
Sure.
And they literally just will deliver power when they're within the acceptable range, and then they will cut power when something is beyond that acceptable range. So the benefit to that is generally that they could be cheaper, but the downside to that is that you have no warning that I'm approaching a temperature issue or I'm approaching a low voltage issue that as a driver in a race, you might say, well, all I need to do is throttle back a little bit and I'll stop that cell from sagging as much and I'll finish the last 100 yards of this race and beat that guy who's barely behind me, let's say, as opposed to in that final stretch, the boat literally shuts off and sits for 30 seconds until it sort of resets itself, and then you can come in your shameful second place. But yeah, so having that ability to be able to see that data is a very good idea. There are a bunch of different things to consider with BMSs, but I guess some of the highlights or some of the things to keep in mind. There's probably, I would say, maybe I'm mistaken here, but there's probably two major types of BMSs, I would say. Ones that use contactors to disconnect and connect the power, and ones that use MOSFETs. And I would say probably on all the smaller ones, the MOSFETs are more common, and on the much more powerful ones, usually contactors are more common. The interesting sort of benefit to the MOSFETs that I found is that they could almost provide the ability for a one-way power solution. So if you had a scenario, let's say with solar panels or something like that, where power is coming into your system and your maybe your battery is currently lower than it would want to be and be still in use. As long as the power is coming in, it will keep it connected and allow that power to flow in. But as soon as you try to get the power to flow out, it will basically stop that. And because your solar panel is connected in that system, that power would essentially get redirected directly to your loads, and your batteries would sort of feather off by way of a pulse width modulated MOSFET connection.
Right.
A contactor-based BMS is going to be either on or off. And so when either an over discharge or overcharge or temperature or whatever the reason is, and with the power either coming in or going out, it just basically turns it off when it's not safe or whatever. And so in most cases, I would say in the case of a PEP race, that doesn't really, it's not a problem because you're generally not providing significant amounts of power, even if you have solar, enough power that it's, you're going to having the BMS that's you chose for other reasons than MOSFET versus contactor is the reason that you would choose it, I would say.
Sure.
But one of the other things that I would mention from a safety standpoint, I mentioned in the trimaran design that we have these three compartments. And because in our older monohull wood boat that we've got, we basically used a 16S lithium iron phosphate configuration as a 48 volt nominal pack, all in one big Pelican case, all in one container.
Right.
And so the BMS, everything's inside, and then you have two leads that come out of the case with the ability to remotely disconnect it if you needed to be able to, have the pack be dead basically. But that pack in itself is not too high of a voltage for safety. Whereas with ABYC, I forget what the standard is, but with the ABYC electric propulsion standards, I think it's 60 volts is the cutoff that they use for, you need to be able to have the systems break down into sub 60 volt components in, by way of switches or disconnects, whatever it might be, in case you have some kind of a situation out on the water, right? So, so in the case of this trimaran, we've got three of essentially what was already in that wood boat, three of these 16S battery packs, all in series, and those together give us a 144 volt nominal battery pack. The difficulty we found with BMSs with that situation is we kind of like the BMS that we were using, but the BMSs have in their specs a number of them in series. What's the limit? And I believe that particular one, you were limited to 2 in series, and then beyond that, the total voltage was beyond the capacity of the components in the BMSs. So we had to come up with something different. And so we ended up finding what I thought was a nice solution, which was the BMS had modules for each group of 16, or each group. They didn't have to be 16. And then the connection between the buses was a CAN bus connection.
Okay.
So the benefit to that, as opposed to other BMSs, will have just a whole lot of the sense leads coming in, and you'll have one module that in that module you have the full voltage of all the batteries potentially, and then so you still have a spot where if you're getting shorting grounding issues, you could still get the shock from the full power of that battery pack. Maybe not quite with the current that would be available through a heavier gauge cable,
Right.
but you still could have a situation, from a higher voltage. So with the CAN bus communication, it's not sending the power through it, it's sending the summary of those cells, status on through the CAN bus, and then ultimately to the brain that is reporting back all the situation and telling those 3 remote, CAN bus controlled modules how to deal with balancing and things like that.
And so the CAN bus is working with the separate battery modules that you've put together to bring the power together,
Exactly.
but also provide you information on what's going on in each of the 3 systems.
Exactly, yeah. And so it just uses twisted pair Ethernet cable essentially between them, so it's not carrying the electricity. So
Sure.
when we turn off the contactors and those battery packs are disconnected from each other, they're truly 3 separate 48-volt nominal packs. And in a worst case scenario, we had a collision and we have water filling in the boat or filling in one of the compartments, we would truly have them separated from each other. Whereas if you had a situation where there was a BMS that did bridge those gaps, you would have to think, how else could you do that? So originally in our 48-volt bank in our wooden boat, we actually have a switch on the case itself that would split it into 2 24-volt packs internally. And the BMS did not separate it. But because it was in the case, we had the ability that it was already inside of a waterproof case, but it still wasn't ideal because if for some reason the case leaked or there was some situation, you still could get the 48-volt shock from that. But it was below that ABYC, sort of recommendation of 60 volts, and it wasn't as much of a concern. But when you're talking about, north of 48 volts, you start to get to be a lot more concerned with what that could do to a person.
Yeah, I think so. On the water, we definitely want to make sure that those batteries stay secure to the hull, so that
Very
way
much.
everything. And then when you're working in the lab, I think the one thing that some of the universities have found would be useful is there's a lot of metal tools, and now you have 2 terminals, and that would create a good circuit for 48 plus volts.
Right.
So, like taping the ends of your tools and things like that might even be like some small common sense things just to make the lab a little bit safer. So for an unmanned team with, maybe they're looking at LiPo or looking at some other, what are some of the battery designs and the kind of management systems that they should be considering?